didn't restart yesterday. I had left open. So now let me recording. Okay, fine. So now just here first you open your this one Docker desktop. Okay, so you would have opened. Okay, it's opening. See, starting the Docker engine. So I will be able to get inside this. First time you will not have anything, it would be empty. I have this because already I have included. So I hope, yeah, it is, everything is stopped, so not an issue. Okay, exited. So now what I'll do, I'll go to the command prompt, and where you have kept that docker.yaml file, you know, right, where you had kept that docker.yaml file, you had created the folder, you have to go there actually. So where we had kept, I'm just showing, this is not required. In the command prompt we will navigate and we will just give what to say, docker.desktop. So users, this was a folder you created, all these are the folders you created, and you had kept the docker.compose YAML file. So you have to navigate here. So you can navigate or copy paste. Okay, go there, cd this one. So it goes here, and from here you have to give that command docker dash compose up. See, now it should work. Executing the command Jupyter, all these things comes. Okay, so to access the server, open the browser. So let me go to the Docker also, it will start running. Okay, go to the container. Okay, come to the Spark. So can you see here the link? It automatically comes here, the Spark link. Last time it was not coming. Okay, so here also that link will be there. Okay, 127./lab. So better way is you have here in the Docker and you can click this. As soon as you click this, it opens. See here, I don't want to restore. It opens like this. Okay, all these are previous. First time what will happen, I'll close all these things. First time you will have something like this. Okay, you can also do Python. Okay, R, all those things. So don't worry all those things. Directly open this Python, which one? Yeah, it's with pyspark only, notebook. Notebook is what we are doing. It has the pyspark thing. Just open this. So this is what the notepad will be. Got this right? So how about you, Sonal? Like you are able to clear that? Means you are able to get into the Docker engine? I can help you, like, so others can also see again. So if they have any issue, because I don't want anyone to do mistakes. Even this is getting recording. Okay, so by next week I want people should have installed and also start practicing, because there will be the classes will be ending on the Spark, maybe maximum another 2 weeks. After that there will be one mock interviews which we will be taking, and there will be a next week I'll be giving assignment, and after that AWS will start. AWS, all those things will not take more time. It will also take 3 to 4 weeks at max. So as I have told, by February it is ending, and you should spend lot of time in your practicing, and you can start attending the interview by March. So you should get prepared by that time. If you are still struggling to understand even the basic thing, then it's very difficult. Okay, so okay, all right, so this is a way to do it. So first time always RDDs are created in Spark. Sessions, Spark contest, Spark session is for the basic entry. So you can't directly run any query, it will throw an error. So first you have to come up with that Spark context, everything, then only your queries start working. Okay, that is a way. So we have done that example and all. Okay, so let me just go ahead with our Spark thing. See why I am doing this, because I don't know like others will do or not. But I have seen in the interview, many interviewers will be very happy as soon as you say all these things, and you will easily get the job. Okay, whatever these things are very important. See, Spark is not something like your database, you write a query and done. Spark has lot of things where as a user you have a control. You can do performance tuning, you can do, because you deal with TBs of data. When you deal with TBs of data, or okay, more yeah, not GBs, TBs of data, there are a lot of performance tuning you have to do. If you don't do a proper performance tuning, it runs against you. Means instead of completing in 1 hour, 12 hours also it will be running. And when you run on cloud means money. For everything the money is charged, and it blasts in dollar. I told right yesterday, in a month, like there was $50,000 where they were spending. I went to the project and I was able to reduce for $35,000. That means every month I was able to reduce $15,000. You can think for an year. For an year it is one how much? 165, 170, around $185,000 I have saved in an year. $185,000, if you calculate in rupees, how much it would be? 185,000. Okay, 185,000. Is it 185,000? 185,000. Okay, dollars. Okay, $185,000 into rupees. How much they got saved? Into rupees. Because lot of money gets spent. 1 crore 53 lakhs. I have saved them 1 crore 53 lakhs. Okay. Okay, they would have paid me less than 50% of this money as my salary, but they would have saved. It is for 1 year. They run this project for lot of years. Okay, and as an architect, I would have not spent 1 year on this performance tuning. I would have spent only 3 months, and they will be saving so much. So that's the beauty of performance tuning. Okay, you will save a lot. And to do performance tuning, you need to understand the Spark architecture. It's not about doing. Okay, like your SQL, you do select star from even here, you do that. That's why I always told learn SQL, because in the Spark also Spark SQL is there. I will not be doing entire Spark SQL, that you have already learned in SQL. So we will be seeing some of the things of Spark SQL and Spark data frame API, where we had done last week, and again we will do next week. So those things we will be seeing, where mainly even in the interview the questions would be on this performance, like architecture of the your Spark and how you will do different things we will be looking. They will ask in interview, and many people might not be able to answer. When you answer, they will be very happy and you would be selected for the Spark. I have seen the Spark interview myself. Okay, Spark interview is not about you do the problem, you do they will directly ask. Yeah. So they will directly ask you what to say, like what is the entry point of Spark. You should know that code, Spark session dot builder app name go or create. They expect that you can't directly write transformation action. They will ask you lazy evaluation, they will ask you white transformation, narrow transformation. Okay, those are the very basic, but I'll go little bit deeper. Okay, it's always good you go and speak all these things, they will be very happy. But yeah, there are a lot of things. I should have done a folder. Okay, lot of things going on. So did we cover this? Okay, this Spark did we cover? Let me open just. Yeah, this we covered actually. So after that, what was the next? Spark, data warehouse we have covered. Okay, no, still there are many things I will be covering. Okay. Okay, Spark. This is what we were doing. Okay, or this one. Okay. Okay. So yeah, I was doing the off way. I had done this. So all these things I had done, and it had beautifully showed. Always your Spark will have client as a client you submit. You submit the Spark application. It goes to the master. Master means driver. And drivers will have executor. I'll tell you, it comes in a worker node. Worker are like employee. They do a task. Task is the smallest unit. Task means some work, some activity, some calculation or something. It will be doing. Okay. So you know this. Your program, it goes to the Spark. What it happens? Okay. Shuffle and all I told. I'll tell you again. What is that? Your smallest unit in the Spark is task. The program is given to the worker node. Worker node means partitions. The worker node will have what? Worker node will have your executors, your memory. Executors means all CPUs, memories, cores, everything will be happening. Okay. So you can play with this. Worker node you can increase 5 CPUs, 10 CPUs, RAM you can increase. Those things I'll let you know. Okay. We call this as RDD, you know. Anything is RDD. Okay. And you know, RDD objects, DAX gets created and worker node will happen. So how this happens, you know, you split into the DAG. We have spoken about this. So same thing again and again I am repeating so that you should not go. Any entry point is the driver program. You will have Spark session or Spark contest. Forget about cluster manager. In Hadoop it was there like Yarn and all. But once we go to cloud, your cloud will take care. Cloud is a serverless architecture. That means all your engines, all these things will be internally taken care by your AWS. So it doesn't come into the picture right now. So you just think about worker node. See what worker node will have. It will have executors, cores. Cores will have RAM, cache, and the lowest unit is tasks. Okay. So this is how the things will happen. Worker node and executor. So it is further divided. So this I will take some other day. I just want you to be strong in this. At least basic. If someone asks, tell me the architecture of the Spark. I have couple of other Sparks also. By that time you would be stark. Like any program, start with driver. Driver submits the program to the clusters. Clusters will have a nodes, worker nodes based on the partitions. If you have 10 partition, you will have 10 worker node. Inside the worker node, there is a task. Task is the smallest unit which does the task. There is also executor. It will have RAM, CPUs, everything defined. Means your cluster means only RAM, CPU. Like that you can understand. You still have a couple of PPTs to understand. So benefit of Spark already we have told like sharing of data, isolation means your task gets isolated to different worker node. Low overhead. It's not like your supercomputers. Every overhead is in a single computer. It is distributed. When the things are distributed, headache is less. That's why low overhead. Sharing of data, same thing. It gets shared. Resource allocation, it's allocated to different resources. RDD, which we have already told. And founder of Spark is Mitai Zaharia. So that's what. So the founder and all, no one will ask. Just I saw here and I told. Okay. RDD, you know. Okay. Computation, it's lazily evaluated. All this should be, by this time, it should be in your mind. Why Spark are lazily evaluated? So these are the odd cake interview question. They directly ask, why Spark is lazy evaluated? You should beautifully present it. Lazily evaluated, since you know in Spark, there are wide transformation, narrow transformations. And anything are two operation, transformation and actions. In that transformation can be two things, narrow and wide. Narrow means like filter union, directly it goes without a shuffle. Wide means there will be lot of shuffles. So because of that, what will happen is it will not evaluate anything at transformation. When you call action like show, collect, count and all, the entire operation, whatever we have done in wide and narrow operation, are executed over there. That's why we call this as a lazy evaluation. If you are able to present like this, they are very happy. They come to know he knows the knowledge and you are inside. I told right at the beginning, you are able to, you should be smart enough. Okay, like Python, SQL, do lot of coding. In this, you are able to run through this PPT, understand all the concepts. I am focusing more on concepts because the concepts is what they ask in interview. Still, yeah, we will be doing the programs and all. That is secondary. Okay, what is the next? Please share the Spark PDF. Yeah, I'll be sharing today. Yeah, I'll be sharing today. I'll be sharing. Okay. Yeah, it's good. Like you have this, you go through that. Don't read about Hadoop and all. Okay. Even I know I don't want to go depth into Hadoop. Lot of unwanted things will waste your time, and I don't want to. It's not more of unwanted, but everything you can't learn and interpret in the entry. Even Spark follows MapReduce. I've already spoken about MapReduce. List of dependencies, functions, okay, partitions. Even Spark is placed on partitions. See, in Hadoop, what is the problem is it stores in Hadoop file system, that is normal hard disk. But in Spark, it is in memory, means in RAM it stores. Always RAM is very faster. You know that. Previously they were telling costlier, now RAMs are also cheaper. Okay. So you know already narrow wide dependency, you can see. Group by key, joins also. Okay, it is a thing. Narrow wide. Lazy evaluation, just now I told you about lazy evaluation. Same thing, it's showing. So once you read this PPT, you will understand based on actions, you know. Okay, so all these are action: reduce, collect, first, take. All these means actions are just to give you an output, to display the output, and also the calculation will happen. Usually even in the organization I have used mostly show and collect. Not much difference. First means first element you will get. Reduce means it is used for summing. Save as text file means you will save the output into the file. Count by key means it counts based on the key. You will have a dictionary value, key and value. For 1, how many numbers are there? For 2, how many numbers are there? Okay, so those things. Spark context, the main entity responsible for setting up jobs, means all your Sparks are jobs. I'll show you the user log, but entry point is Spark context, which you should know. Storage level, you can also smartly store. See, whenever you are executing some operation and again, you can store that operation in the memory, so that taking from the memory will be faster. You can also store in disk. There are a lot of concepts, like some data will not be able to fit in memory. You would have put as 32 GB memory, but your processing is happening 40 GB. There will be a disk spilling happening. Disk spilling means, okay, disk spilling means from the memory another 8 GB data gets spilled, because you don't have so much space in your memory, because you have used the memory of RAM of 32 GB. RAM of 32 GB. See, all this, please listen the recording and make a notes. I will give you this PPT, but make a note. All this plays very important role in your interview. Okay, you are understanding, right, how much Spark has the concepts? Because Spark, as a user, I will have the entire control. It's like I am assembling. It's like you get a vehicle which is deassembled. How you will assemble the Spark? It's not like in the UI, like database, you write a SQL query, select, start, done. In Spark, you should know behind the scene what it is happening. When you know behind the scene only, you can write the program. You can't write however you want. If you write however you want, it screws up the entire performance. And you know, you will be dealing with huge volume of data. If you are playing with GB of data, you need not to worry. Okay, you are lucky. Okay, you will have a very easy job, easy work. When always as a data engineer, the trouble happens when your data is too much. When your data is in petabyte, when your data is in terabyte, without understanding the behind scene, you can't write your query. Okay, you create, like, you can't randomly create 50 partitions and you run. What will happen? Skewness will happen. What do you mean by skewness? Skewness means one in your 100 partition, okay, only 40 partition are utilized properly. In another 60 partition, it is underutilized. Underutilized means, okay, overutilized, underutilized. Imbalance of partition of data. That means it will have too much of data to process, it will have less data to process. Because of this, what will happen? Again, it will take lot of time to process. Lot of time means lot of money. Lot of money means your business or will tell to your manager why you are spending so much money, why it is taking so much time. Your manager will come to you and tell, boss, you have simply written some code, it's not working the way it is done, just check the code and do. How you will check the code? Check the code will understand by the thing whatever I am telling to say you. First is the concept, you have to understand the concept. Okay, not all the partitions are utilized. How you will see that? I'll show you that how to see the Spark log, how to see your job, how your job gets divided into what? Your job gets divided into this one, stages. Your stages gets divided into tasks. Whether you have properly tuned all these things, proper CPU is given, then you reduce the partition, then you will see whether you have properly given the broadcast join. I have told you about broadcast join. Can anyone tell me what is broadcast join? This is again very important concept. I had spoken about broadcast join. When you have a small data, if you are joining two tables, one table is very small. We have seen the code also, example. Okay, so with some country table has only 5 or 6 records where it is only 2 MB of data, but your one more table is very big data. Okay, so that time you have thousands of GB of data. That time, rather than doing a normal join, if you do normal join, shuffle will happen. Joins will deal to shuffle, you know that. Keep this in all your 100 partitions. Okay, country table in 100 partitions, so that it does not do shuffle. Shuffling is always a costly operation. See, in Spark, main thing what as a architect or performance tuning I see is, I will try to avoid or reduce the shuffle. I'll try to avoiding is difficult, or reduce the shuffling. To reduce the shuffling, lot of things has to go in my head. Like, I have to see all these things, how the table are joined, how the partitions are happened, all my 100 partition are used, whether skewness is there disk spilling is happened. Based on this, I'll do remaining lot of things, which we will be learning. Getting right? It's not like you simply write the query and done. You got an output. It's good. It's good when, if you have only 100, or I can't even say, if you have 50 or 100 GB of data in your project. You do, however, it doesn't screw up. Okay, but usually sparks are dealt with. 1 minute, I am getting a call. Hello.
Hello, Manali idira?
Manali idini.
Bartiddare ಒಂದು ನಿಮಿಷ.
Sorry, okay. ಇವರು ವರಲಕ್ಷ್ಮಿ ಕಾಲ್ ಮಾಡಿದ್ರು, ಬರ್ತಾವ್ರಂತೆ. ಗೊತ್ತಿಲ್ಲ, ಬರ್ತೀನಿ ಅಂತ ಕಾಲ್ ಇಟ್ರು. ಓಕೆ, ಅದಕ್ಕೆ ನಿಂಗೆ ಡಿಮ್ಯಾಂಡ್ ಮಾಡಿ. ಓಕೆ, ಬಾಯ್. Okay, all right. So yeah, so 50 or GB data of your project, you are lucky. Means there are some projects agreeing you need not to worry about all these things because your data is very less, 50 GB or 100 GB. This is also okay. So you need not to follow lot of performance technique. They would have given some CPUs like 50-60 CPUs. Okay, it will work fine. Okay, so but when you have instead of GB, TB of data, because I have worked, it was my biggest struggle in that project in my career. Okay, they had more, it's not TB, I had 1000 TB, petabyte of data. I am giving you an example. If you have so much data, you can't simply write the query. Every query you write, it screw up, it gets screwed up. Okay, but I'm not scaring you guys, it's okay. You are just a fresher, no one will ask you all this a lot of things where you do. It is a responsibility of an architect to work on all this performance thing, and you work on the development. They create a framework, they will create a query, you have to use this kind of query and all. You have to understand your stages, you have to understand the task. They will teach you for one thing. They don't teach you, they will tell you. You have to see all your job stages, partitions, because I see there is a skewness. They will tell skewness. You should understand what is skewness. Okay, maybe you have to, there is a disk spilling is happening. Somehow try to reduce the disk spilling. This is what architecture will see, understand, and tell to the developer to see. Like you have to just manage the disk spilling should not happen because of that, and you should also reduce your shuffling. A lot of joins group by unnecessarily you are doing. Try to reduce. Try to think of writing a code without that. Okay, try to use some way. There are, that is what, like, which happens as an architect. Architecture will not teach you the way I am teaching you. This means that, that means that. No, he will tell you. Then smartly you will understand. Okay, but there will be a senior developer. He might teach you. I don't know. It depends on a project. If project is screwed up, everything you have to do. If you are telling you are an experienced guy, 2 years, 3 years, they will expect you. If you are going as a fresher, they will teach you. But in the interview, if I am speaking about interview, you know all these things. If you speak all these things, you are pakka able to clear an interview on the Spark. Okay. If you don't know all these things, I will give you 5,000 programs. You can't clear any Spark interview. So these are very, very important. And focus is here. Okay, in Python, if you remember, I never did even single of the theory thing, because we need not to know. We need not to know. It's only on the programs they ask the question whether you know that or not. But in Spark, as a data engineer, we should know each and everything behind the scene, because Spark is dedicated for data engineer projects only. And we need to know that. Okay, and I am trying my level best not to teach you once. I am teaching you 5-6 times, and with different PowerPoint presentations, which I will be sharing. Okay, of heap and memory, I will see whether I want to teach you or not. Okay, so this and all, yeah. Understanding RDD operation, this is what yesterday we stopped. Like, you know, like what does map does, flat map yesterday, like map will split, flat map will do like this, and also later after splitting like this, it will give you, you can assign word using lambda. You know, like, this is a Scala Scala syntax, but in your Python you can use lambda comma word comma 1. It comes here like this. So that is what this is, again Scala they have showed you. Okay, so how it does map, and after that reduce by key and collect as map is an action. This is an action. So how it happens internally also, it has showed, like stage 1, because everything will be jobs. Under job there is a stage. In stage all these are tasks. This is one task, word once, means some operation it happens, like counting, summing, all those things. And driver is a main program. It's like a manager. It first sends, can you see? Okay, yeah, driver is a manager. Okay, and this is the first operation it executes. Why? Can you see here stage 0, stage 1? Why? Because you do all the thing, but when you do action, that is count, then only it starts working. So this is a stage 1. Count will, as it's a lazy evaluation, it does all this operation, counting line, giving numbers, doing calculation, everything. Okay, so execution plans, there are a lot of internal architecture. Okay, so stages, what's happening. This is a Scala thing. Caching and storage. I've already given high level, that's more than enough. I need not to speak all these things, then you will go mad. So caching, there are two ways. In your code you can use persist or cache. Means, yeah, one method, persist also caches, means permanently store, or you can use cache. Compute cache, okay. This storage level, okay. Data format, again I'd asked you different data formats. So walk through submitting Spark. As you submit the Spark application code, okay, not required. Okay, what is tag? Directed acyclic graph. Okay, stage. Yesterday I spoke about DAX. Okay, executors, shuffling always takes time. So the main thing is to reduce shuffling, means joins, group by. Is there a way to reduce, or broadcast join? If it is small table, can you do, see, data shuffling? Okay, hash shuffle, sort shuffles. There is a different kind of shuffle. I'll tell you. I don't want to tell all the concepts. The first thing is I'm clearing couple of concepts again and again, so it gets to your mind. Okay, rather than speaking about all concepts, there are some concepts like executors, different kind of shuffle, which I'll keep it for later. See, so much is there. See, the which I am not doing, not showing so much interest. You see the recording, and according to the PPT, you neglect it. Okay, it's not like whatever is there in PPT we have to do. You will get more information. Okay, so let us go for the next PPT. So, okay, so this is who has created. See, you know this. Before they were using disk, flash means USB drive. After that, I think like this, it came. Historic cost of memory and storage was too much. Memory grid. What is Spark? This and all, you can read it. 100x faster. That's why everyone uses Spark. We are using Spark. Spark is used whether you work on any project. Microsoft Azure project, AWS project, Google Cloud project, only Spark project. So Spark is common. Okay, so you have to learn Spark. So obviously with Spark, we have seen this diagram already. See the Spark, how much it is used. Spark is used so much. Okay. See the difference. Beautifully they have given through diagram. If this is HDFS, it is through the disk. Hadoop means Hadoop. Previously to Spark means to the cloud, Hadoop was there. I had worked on that, so obviously we will not work on that. So why they use Spark instead of Hadoop? Because it was storing, some actions happened, some iterations happened, some calculation. It is saving into the hard disk. Again from hard disk it is reading. Again some calculation is happening. It is going here. Okay, can you share the screen? How it's done? Because the link you gave us is not the same. I didn't understand which link I gave you. I didn't give any link. Is it attendance link you are telling? If it is attendance link, I can just straight away. Actually, why don't you save the attendance link by yourself? Installation link. I didn't give any link for installation. Which link I gave you? Link you gave us is not the same. You can check once I have installed. Okay, alright. I will check with you, Vijay. Not a problem. We will sit for a couple of. Okay, alright. So, yeah, you know, like what was the problem with HDFS? Okay. So concentrate on all these things. See my recording again and again. I am telling you, in Spark this matters a lot. You know, you spend like 4-5 hours in practice, done. They will ask you 1 or 2 questions, how to join, how to union, whatever, in Pythonic way or something, done. But means already we have done couple of things. You want to rename a column, struct type, struct field, all those things. You write a syntax. They will not see step by step every syntax. They just look whether you know struct type, struct field, whether you know different kinds of functions. We are still doing function alias, lit function, so many things. Whether you are able to join. Some of the things I have to do. Whether you are able to get that CSV file from somewhere, JSON files from somewhere, create a data frame. You know how to create a data frame. After creating a data frame, whether you can do Spark SQL, you already know SQL, whether with that you can do. You have to just make a step. You practice 500 programs, 100 programs, you will become perfect. Okay, but you will become perfect good. That is not required for me to show all 500 programs. You have to practice, but always have a mental mapping. Okay, any file, see, make like a story. You need not to practice like any mad person, like 500 hours, 600 hours. You need not to spend. Like any file comes, see, that is how I am also teaching, right? Any file comes, what we will do is, you get a raw file. Okay, I have not showed you how to get a file. I will show you that next week. But I have showed you a data. We created a data preparation we did. But step is, you get a data file. That data file, what you do, spark.read.csv, like that it is there, which I will show. After getting a data file, next step is, you have to create a RDD. Everything is an RDD. Create an RDD. There is create data frame. You can do a create RDD. Data frames is created. Then after creating it is an empty RDD. But you already have a data. You just create RDD, and later you want to do a SQL. If you want to do a SQL, do create or replace temp view. Give a name. Then spark.sql. Do all your SQL programs which you have learned. Mostly it works. Whatever you have done in your Oracle and all, there will be some changes. Okay, that's all it will happen. Windowing function, they might ask in interview, do a windowing function. There are two tables. I want to get the in the department, 3 department, what is the maximum salary? You know windowing function, dense rank, all those things you have learned in your SQL. I will not teach you that. You should be smart enough to do that by yourself in the interview. Okay, getting that right. Or they will not ask you, they will ask you Pythonic way. That also we had done, like df select, after that some column, group by, dot group by. If you see my notes, we will still do. So if you know this mental mapping, you practice 100 programs, not required at all. With that mental mapping, you can tell in the interview, you can also do that. Okay, because you already know SQL, everything. But these are the questions where you have to concentrate, because this you directly read, you will not understand. Getting right? Okay, data sharing in MapReduce. Okay, see the Spark, it is a RAM. RAM is always faster. That's why you see at the beginning 100 times faster. See, 10x to 100 times faster. Then network and disk. These are network and disk. What will happen? So some performance they have given. Performance means it is slow, means it is faster. It is taken only this much time. This pink or red is Spark, blue is Hadoop. Okay, how Spark works already you know. See the beautiful diagrams, the more diagrams for you. Forget about cluster manager, Spark context. You give a program, goes to the worker node. Task is what it means. Worker node means it will have a lot of CPUs, lot of cores, not one CPU. There might be 50-60 CPUs in one worker node. That means there can be 500 GB RAM. There can be so much space, RAM, memory, processing speed, everything. Okay. RDD you already know. Different levels of caching. Memory only, memory and disk. It has rich APIs. Rich APIs means same thing. Group by, all these things I have already told. Map, flat map. I have also asked you. You just research some of the things. Filtered, union, reduce, join, count, all those things. Beautifully they have given. This is your This is your Spark. This is your Python. Lambda, you know, lambda is an anonymous function. In Spark we mostly use lambda. You want to, wherever it comes, if the same function come, x plus 1 you do that. Parallelize is for creating RDD. Seeing this you should understand. This is a list. You know the square bracket. Next I want to create an RDD. Anything and everything in the Spark is RDD. Next you are, whatever you are doing, you are trying to add this is a single x. You are adding 1 to everything. X plus 1, 1 plus 1, 2 plus 1. See here, 3 plus 1, 4. Collect is display. Means this is a transformation. This is an action. Whatever you do calculation till x plus 1, it does not do anything, because Spark is a lazy evaluation. When you do collect is an action. It does not only displays the data but also does the calculation. Are you able to understand? Seeing the code you should understand. That's the beauty. When you understand like this, right, It's very easy. It will be in your head. In interview you will clear. While working it is fun. Okay, you can't mug up. Okay, don't mug up, because this is now today. If you had not learned the Python, you would have gone mad in understanding Spark. There are many people who do that mistake. They try to learn the Spark without knowing the Python or whatever coding language. If you don't know Lambda still now, if you don't know map, how it is working, I am sorry, because we have taken lot of classes. We have also done filter. While doing after Lambda, map I have done, filter I have done. So why you do filter? You are doing filter, only get the numbers which is greater than 3. Okay, you are getting this output. Okay, so you can try all these things by yourself. Now you understood, you did a postmortem of this. First you did a list, or always you have to create an RDD in Spark. Then this is a transformation. Only with transformation it does not do anything. When you do action, it does all this activity. You tell like this in interview beautifully, you will be very happy. Same thing. You have the list. You do parallelize RDD. You do this map and all is a narrow transformation. What it does, it is pairing. Somewhere you will have, okay, x, see here you have done x comma 1, means everything you are giving 1 comma 1. After x you are trying to do a key value. Key value means dictionary. Okay, they are trying to do a dictionary. See, with your Lambda you are able to generate this to dictionary. You just did like this, x comma 1, means for everything add a 1, that's all. This is a x, 1 comma 1, 2 comma 1, 2 comma 1. Okay, so next is what you did, reduce by. Reduce by, go postmortem, internal. Reduce by is a costly operation because it's a wide transformation. Lot of shuffles will happen internally. Okay, so but yeah, when there is a requirement, I can't avoid, I have to do. But understand like this, seeing the code I am able to speak about the behind the scene, because we have seen lot of architecture. Like this only you have to understand. Reduce by means it is summing, reduce by key. We have only reduce by also, but when you have key value, you have to use reduce by key. One is key, one is value. All these things we have done this. 1 comma 1, 2 comma 1, however they have done. A plus B they have done. What they have done. Whatever 2 is there, they have added. 2, how many 2's are there? You have added. 1 plus 1, 2. If 3's are there, 3. Whatever you can see. 4 is there. They have just added. Okay. See, I am not doing. With this only you will be able to understand. But even you can do like this also. Same activity, they are trying to do this. This is a Pythonic way. This is a Pythonic way. They have used key values in, no, they have extended actually. They have extended. Okay, for keys value, you know this. I need not to scratch my head in teaching you. You know all these things. In Python we have taught you. Just group by values collect is a part of Spark function. You know for, you know in, you know print, everything. So list is there, parallelize is there, lambda is there. Okay, actions, you know count is an action, take is an action. When you can try by yourself what is the difference between count, take and all. Fault recovery, I told always RDD. This can be also an interview question. In interview they will ask how can you recover. Okay, means whenever there is some issue in the middle it stopped, how it can recover. As RDD is immutable, you know this. It is recomputable distributed data set. Means where it has stopped, it will go to some other cluster and again it will rerun from where it has stopped. So you need not to worry. And also it builds a DAG, means lineage. We have already seen DAG, directed acyclic graph. That means everything, previous operations would already be saved like a RDD. Yeah, it's a RDD, same thing I am telling. See, same thing it has told. Filter RDD, mapped RDD. Somewhere it stops here, till here it is there, again it recomputes. Okay, so we will be doing with Amazon, AWS. So this and all is not required. It's just an example. See here, how big the code if you want to do in MapReduce, so big. In Scala also, this is the way you do. In Python, now you are able to understand in Python. This is a way to get the text file which I will show you. Flat map, you know how to count the file, lambda reduce by key. Okay. Okay. Actual demo. What is the demo? I will pass this all this PPT. It's a good PPT. See, by just teaching all those things, every code you are able to understand. So what this parallelize is? This is a list in pure Python. We have already learned. Parallelize, I have told. Creating a RDD. We have seen practically. Parallelize and create data frame. You have to create an RDD and you have passed this list, my list. Then this is a transformation here. This is a transformation. In Informatica, it is a graphical user interface. You drag, drop. You know Lambda. Lambda is an anonymous function. Used to do all this activity. Map, you know. One input, one output. See, one input, if one output it is giving. Collect is an action. That way you learn it. Please learn that way. You become super strong. Okay, I am able to train because of that way. Okay, it's not something like I am working only in this technology, and also this, I am also not a developer right now. It's been like a long. I am doing this. I am doing lot of other things, like I do architect of all the projects: Spark, Snowflake, AWS, Azure. Okay, so and performance, those things. Many things I do that. But yeah, this is it's not like I practice 100 times today and I come and teach. I know this. This is enough for me to just understand. So you also be that way. In interview starts with, it's a pure Python. If you want to capture an error, you can filter. Starts with error. See, in the interview they can ask you a smart question. How will you capture the error in your Spark? I write a small code. Wherever I filter, wherever in my code, if there is an error, I just try to capture that. Starts with error. So I will have that Spark log and I'll keep that. Okay, there can be new questions, any questions they might ask you. Word count example. See, counting the word. Flat map, lambda. I have just showed you again and again. I am just showing you. They have just told in Hadoop 10 hours, in Spark it is 1.5 hours. I don't know what is this full grade, half grade. I have to read this. It's not required. Okay, good. Lot of good information. I think we covered this. Okay, which Spark I covered? I should have downloaded this. Okay, it is gate 02 something. Gate 02. Okay, but there are this one. Okay, it is a glue. This we covered. Okay, Spark data frame I didn't cover, which is most common what we do. Okay, some Chinese language it is there. See why I am showing different PPT and explaining same, because it goes to your mind and you never forget it. And lot of people will have confusion. One time I teach you, two time I teach you. I am teaching you 4 to 5 times. It becomes a revision for you. Okay, and you should be able to present. Same thing. Driver, it's like a master. Spark context. Workers will be there. Okay. Python you want to run. py4j is for, because see, one thing you have to understand, Spark is not developed in Python. Python just came 3-4 years to work with Spark. Spark was developed in Scala. Scala also uses Java. Scala is developed in Java. That means Java virtual machine is used in Spark. You have to understand. So here Python is used here. First time JVM, as you do worker node, this one, JVM gets created, but JVM cannot directly read by Python. So py4j, to read the Java virtual machine in a Pythonic way, this py4j is called. I don't know whether I am going deep and technical. I felt like telling you, but it's good you know all these things. Okay. Okay. See here, here I didn't observe. They have told Java Spark context, because if you see, I can write Spark even in Scala, even in Java. I don't need Python only. Why Python came? Because Scala writing, Java writing was very hard, very difficult. Then Python came. Python is very simple. But for that, internally Spark is written in Java. Okay. And to convert that to Python, you need py4j, the file. So that is internally there. That's what this picture depicts. So py4j, then it is Spark worker, Spark worker. It's good you understand, or else also neglect. nothing to worry, too much technical. Okay, it's an understanding behind the scene. See here, Java Virtual Machine, JVM. That means Spark is developed in Scala. Scala is developed in Java. So yeah, Spark is developed in Scala. Scala is developed in Java. Obviously, Scala is developed in Java means the internal of Spark is Java Virtual Machine. But Python can't read directly Java Virtual Machine. py4j file is required to convert that Java Virtual Machine to a Pythonic way, and with that this happens in driver it does takes care of all these things, and later Spark worker, Python worker gets created. That's why you see all these things. Just I saw this diagram and I started explaining this. Write program using RDD API. Okay, see here you have learned your why I told you at the beginning to get training on SQL for the same reason. Spark SQL you can do. Everything is Spark. Everything is SQL, but it is a Spark program. Okay. This is a Pythonic way of doing. Means this is a Scala, but in Python if you do, it would not be like this SQL. You will do filter, you write a case. We will see some more examples in the next week, not week. One more important concept is there. I think it's too much of technical things going on. Okay. Let me give you some 15 minutes break. We will connect around 4:30. Okay. So even I need a break. We will connect at 4:30. If some people are trying to install, try to install Docker and just see that. Okay. Okay. All right. We'll connect at 4:30. Thank you. Okay, all right. Let us continue. So there is something called catalyst optimizer. Okay, this is again an important interview question. So what do you mean by catalyst optimizer? See, what happens is spark can be run. Okay, if this is a spark, so this is a spark. Spark can be run using Spark SQL and also data frame. Yeah, data frame API or a Pythonic way, frame API or a Pythonic way. Okay. So behind the scene there will be something called catalyst optimizer. Catalyst optimizer. So what does this catalyst optimizer does is, okay, in Spark SQL you wrote select star from EMP. Okay, so later what you did is you did what instead of where, okay, you have to filter only department number 20 something. So you didn't filter. Okay, what you did was select star from department number 20, join department something, you dot emp dot department number equal to dpt dot department number. After that you again joined, okay, something, okay, something, what is that table, some sales table, again you did on. At the end you are trying to filter where department number equal to 20. So this normal database, what will happen? Normal database, if you do that, if you have 1 lakh record here, 1 lakh department here, or 10,000 department here, okay, it joins all the data, and at the end it filters, because you have done a bad coding. It's a bad coding. At the beginning only you should have smartly filtered it out. Okay, maybe after joining where you should have given department number equal to 20, something like that, so it picks up this much code. But you have not done anything, it just joins, again it joins. At the end there are crores of record, then you are filtering department number 20. The time consuming will be very high. So what does catalyst optimizer does is, first it analyzes the entire code and it comes to know, yes, put department number 20. So first it does filtering by itself, internally it does, where department number equal to 20, it will execute itself. And because of this, what will happen, even you put the query at the end where condition or here, catalyst optimizer will optimize all your code, seeing the entire logical code, and it at the beginning only it will exclude all the department number. If you have 500 department number, 50,000 department number, it will exclude all the department number and keep only department number 20 and does remaining operation. That's why catalyst optimizer is there in Spark, and it optimizes your code beautifully. So you have to tell in the interview whenever they ask you about catalyst optimizer. Okay, so that's what they have given. All these things is they have done filter and all, but simple way, whatever I have explained. Just have this example whenever they ask catalyst optimizer. Nothing, not so much to go ahead and speak. Easiest way to write efficient. Okay, this is a efficient way. Internally it does catalyst Apache Spark optimizer. That is what they have given, all these things. Okay, I don't want you to go ahead and understand all these things. Okay, so what will happen internally, that's what it happens. Okay, I feel like it's too much for you guys. Is it too much like for you guys? Are you able to get whatever I am telling, or it's going above your head, or it's okay? Okay, okay, I'll take for some more time. I know like it will be going above your head because I speak about something again something, but yeah, can't help. The reason is I don't think so. Not everyone will cover this, but I am covering because I know the very much importance in Spark. Spark is not about writing code. Spark is understanding this because it's like you get a deassembled computer, you assemble however you want. That is Spark. Spark is always is in the hands of the user. So we can do lot of coding, lot of tuning. Okay, and okay, so let me continue. As you know, see, I was telling at the beginning it analyzes the code. They have given one beautiful information here. Can I zoom it? They have given at the bottom. Yeah, this information. See, any code at the beginning, it would be unresolved logical plan. You write a code, internally what happens? So it would, your code would not be resolved. There will be a logical plan which happens. There, entire code, even if you write 500 lines of Spark code, internally it understands. Okay, this code is proper, or there is an error. There only syntax error will come. Or it finds the proper code. Yeah, it tells logically this code is proper. Okay. Next, it optimizes. Optimizes means there are a lot of ways to optimize. I don't want to go behind that. Then you will get confused. Optimizing, they use push down optimization at the source level, target level. There is a Boolean optimization. There are a lot of optimization which happens. Means your code is internally optimized. However you write code. Okay, but not with partition everything. Partition, executor, you have to understand. Code means the normal coding, where, join, on, whatever. Just now we spoke, right, about that. I am not speaking about cores, partitions, everything you have to give properly. That and all it will not take care. It takes care about your code. We are speaking about code. If you write the bad code also, okay, so it internally understands. It internally parts. This is a bad code. If you see here, where department number equal to 20 is written below, but internally it picks up and tries to put department number 20 here. That is what logical optimization. Even if you have 500 lines of code, it completely scans your code. Logically it builds, optimized way it builds. That's what optimized logical plan it builds. Okay. Next, in the physical plan, it tries to find your in the physical plan, there are 2 to 3 ways of executing your code. 2 to 3 ways of executing your code. Okay, it would have made 3 or 4 ways of logical coding. Like this way is also correct, this way is also correct, this way is also correct. In physical plan, what it does is, in physical plan, it does the cost-based optimization. Cost-based optimization means, I was always speaking, right, money, money, money. That's what internally also it does. Cost means it's not money, here it's time. Okay, it would have made 2 or 3 ways of executing the code, right? It will just find out which is the least possible time taken with cost effectiveness. It has its internal compiler to calculate the cost, time, everything. With that, it comes up with final one physical plan, means one code, and that code gets selected physical plan, means out of 3 or 4 it gets selected, and final code is generated or executed. That is what internally it happens. That's what they are spoken here about catalyst. Catalyst, first it does the query plan. How it does the query plan? First, your code will not, you don't know whether your code, compiler doesn't know whether your code is proper, free from syntax issue or whatever. That's why it is written at the beginning, unresolved logical plan. After your code analysis by the Spark, JVM, whatever it is, so you are logically optimized. There are 2 or 3 ways of code. It internally builds off. Okay, this is the best way, this is the best way. One way will be like this only, where will be at the end. One more way, where will be here. One more way, some other way. Like that, 3 or 4 ways it builds the logical optimized plan. It tries to say whether at the source we take this data, it's better, or at the target we join the lookup. So many things it calculates, and it comes up with 2 to 3 ways of optimized plan. In the physical plan, it checks the cost and time and whatever way in that 3 or 4 ways, and finally the final code is selected. That's why it is written. See, that is also there. What I told, I am observing now. It's good. Okay, where it went? What I told is written here. If you observe here, what it is written? Where it went here? Okay, it went below. Okay. If you see here, you will see here cost model. Cost model means in physical plan it checks for cost, means you can speak about cost and time. Less time and less money, whatever internally means in the lesser time and more efficient way. Cost mod. In that 3 or 4 ways in the logical model which is selected, it picks the final cost model. Okay, and that code is selected and it is run, and then RDDs get created. That's what you are seeing this diagram. Behind the scene it happens. You need not to worry. Behind the Spark does it. It's not to do with your partition, not to do partition and all you have to give properly. If you skewness and all will come if you don't give. It's about your coding. When you do the code, when your code is not syntax means not properly optimized, your Spark will optimize itself. Your database will not do. Okay, that's what it is written here. Okay, I hope you understood what I was trying to say. That's what Catalyst Optimizer. It's a good interview question. See, in the interview they will ask only about this. So you have written a bad code. How does the Spark recognize this? The way I told you, if you try to explain this, they will be pretty much happy. Okay, there will be a Catalyst Optimizer. What happens behind the scene is there will be unresolved logical plan. That logical plan is passed for analysis. 3 or 4 ways of optimized logical plan will come. Next it is moved to physical plan. There the cost model, cost based optimization happens. Cost and time based optimization happens, and with that there will be one proper best code selected from that physical plan, and that goes as and becomes RDD. I told Spark first is RDD, but before creating RDD, see behind the scene what all will happen internally. This is what internal things you should know. You should be strong on all these things. Interviewer will be very much happy and you will clear the job. Okay, I don't want you to bug with only coding everywhere. SQL coding, Python coding. This is an opportunity to know theory, tell theory, and make the interviewer very much happy by telling all these things. Yeah, coding is also required. We have done, we will do in coming classes. Not to worry. A data frame, as you know already, data frame means tabular structure. That's all. I don't want to speak the same thing again and again. I've also given you what is JSON, Parquet, all those things. Try to come up with that. Okay. Tail, it seems, I don't know about that. Data frame SQL. What it is telling, high level and easier to optimize. See, okay, Scala, okay, whatever. I don't want to go to this. Let us cover one more PPT for the day. After that, we will see who have installed Docker and Spark is running properly. We will just see one person's laptop. Okay, why my mouse is not working now? Okay. So we did this data frame, we did Spark introduction. We'll see this. It's all now. I think it is almost same. If I run new PPTs, almost whatever we have covered, it comes again and again. Okay. So anything new? See, already you know this diagram. There are different ways to deal with Spark. Means to get the data, Spark streaming and all we were not seeing. Spark SQL we have seen. Okay, so Spark is 100 times faster. You already know this. High level operators. See, you know this Spark code already we know. This is an example to count the line. They might ask in interview, because if you are seeing in all PPT means this is a common question in an interview. In the coding they will ask how to count number of words, same word. Hello word like that you have. How you can count hello is 3 times, word is 5 times. Just they will give you one word like this. Okay, so hello world, like this it would have been repeated. How to count how many times hello has come, word has come? Please write a Spark code. Okay, they will give you, because I see in every PPT they have asked this. They might ask the same question. Okay, so flatten I have already explained. Okay, coding, if I do coding and show you output, you will not understand. But splitting everything, what is flat map? There is a PPT with diagram also, flattens. Okay, that means hello would be made like this. Word, it flattens everything. Then you do map and give, yeah, with flatten internally it happens like this. Then what you do with map, something you do the code with map, you give 1. That means what will happen, for everything it just adds 1 so that at the end you can count group by or group by key, whatever you give you can count. Okay, okay, after this what they do, that's what they have done. Flat map, flatten, split also they have used, so that it's split with the next line. And word 1 they have given, so that it comes here, map is there. And reduce by key. Okay, reduce by or reduce by key, so that what will happen with this key, it reduce and it comes at the end as you use reduce or reduce by key or edu. For all this thing by yourself, now you need an Docker and the Spark, so that you can work by yourself. Now you are able to understand after me explaining you so much of the thing. So hello is 3 times, okay, 2 times, word is 3 times. So it happens like this. I see in every PPT this, that means this is an hotcake interview question. How to count number of times a particular word has come. Write a Spark code. Okay, you take a file and you use a flat, you know lambda, reduce by key, that's all. But understand, don't mug up. There is nothing of mugging up. Okay, architecture, you know this. Many times I have done. Now I have become strong teaching you. Driver, that means one worker means RAM will be there, input will be there. Inside this lot of things is there. I will think whether to teach you in the later classes. If I teach you everything, you will go mad. Okay. This much though, by this time you know driver is the main thing. It's like a master, and there will be worker. Worker means 3 partition you would have given. Okay, and worker will have task. Task is the thing. RAM, CPU, everything will be there inside this. And RDD, you know, transformation action, you know. Okay, how it calculated inside. Every RDD will be in memory, not in disk. Why it is disk means not your hard disk. Okay, it would be something memory only. I don't know what is this hard disk. Okay, everything should be in memory basically. One memory. Disk means I don't know what is that. It's a hard disk or whatever. Shuffle is always costly operation. Group by, reduce by, sort based shuffle uses shuffle buffer which reduces. So don't get complicated. See, more shuffles will happen means more garbage collection, because lot of data goes swapping from one partition to another. JVM memory allocator, that means sometime your Java memory gets filled and you get an error, out of bound exception. There might be an interview. This is a common thing in Spark which happens. In interview, some interview they might ask, tell me why Spark gets out of memory exception. 1 minute, I am getting a call. ಹೇಳ ಏ ಬೇಡ, ನಾನು ಜ್ಯೂಸ್ ಕುಡಿತಾ ಇದ್ದೀನಿ, ಅದೇನು ಕಾಫಿ ಕುಡಿಲಿ? ಇಲ್ಲ, ನೀನು ಕುಡ್ಕೊ. ಏ ಆಲ್ಮೋಸ್ಟ್ ಬಾಟ್ಲು ಪೂರ್ತಿ ಹಾಕೊಂಡಿದ್ದೀನಿ, ಚೂರು ಇರ್ಬೋದು, ನೀನೇ ಕುಡಿ. ಆಯ್ತು, ಬಂದು ಕುಡಿತೀನಿ ಬಿಡು. ಓಕೆ, ಬಾಯ್. Okay, can you see here? Tell me why Spark gets out of memory exception. Can you understand how the questions can be? Questions will be like this. For this, I can't directly teach you. When I teach you all these things, then it would be easier for you to understand. See, what happens now internally, lot of shuffle happens, lot of garbage collection gets filled. JVM, you know, JVM because Scala, Spark is written in Scala. Scala is again is a Java thing only, means it is written in Java. So JVM would be behind the scene. JVM Java virtual memory allocator. Means it allocates, and as lot of shuffle happens, the garbage collection means a lot of junk data, junk thing you will not close. Some file would have been opened, some shuffling will happen, because of that some process will be there. So all those come into the garbage collection, and you are not closing or not cleaning. What will happen? It will overflow and you will get out of memory exception. You will get out of memory exception. Getting that right? That's why there will be an interview question, out of memory exception. So that's what. Shuffle ensures the Spark can still serve shuffle files even when executor or garbage collection. Okay, whatever. I don't want to read that and explain you. Time sort. Okay, the memory consumed by ODDs. Okay, map reduce model, Spark support 80 other transformations. Okay, which one I saw? Okay, we did this one we had done. Spark SQL, this one I will do for today. Okay, this is Spark SQL. That means you can write SQL. This would be simple. Spark SQL, see 2010 Spark was there, but Spark SQL 2014, by the time we started using it was 16-17. As soon as it started, no one will start using. Introduce the program structured processing. It provides same as Spark SQL, provides programming abstraction called data frame and act as distributed SQL query engine. Spark is distributed. See, what was the challenge? This is semi-unstruct perform ETL, perform advanced analytics, challenge, solution, a data frame API that can perform relational operation, both external data source, Spark. Okay, highly extensible, optimized catalyst. See, now you should be able to understand catalyst optimizer. So internally it builds the code and swaps your code, like where is not written properly, let me write, or else I have to get 1 crore record. If I write where at the beginning, I have to get only 1 lakh record. Can you understand? So all these things uses feature. SQL architecture, always RDD, you know this, schema RDD, data frames. You create a data frame, create a temp view and write your SQL query. Different sources, Parquet, JSONs, languages, Python you can use. Spark SQL architecture, same thing. They have just told, you will understand. See, while writing a code, I gave you schema, table was created, records, what is there inside. You create a temp table, create or replace temp view. You call it as a data frame. Okay. So features, same, RDD will be there. Unified, load the query, JSON file. We will see how to get all this JSON file and all next week. So I am not doing, it's a part of Hadoop. Okay. Same thing, scalability, Spark RDD. RDD is, you know it already. RDD is function data structure. Okay. Map filter, all are RDDs. Formally, read only partition collection of records. Obviously, it's read only. RDD is immutable. So it's read only. It's partition collection of records. Okay. RDD is fault tolerant. All these things you know. Same thing. See, any PPT I take, same information. Now you know what would be the interview questions by this time. Spark SQL, a distributed collection, good optimization. Conceptually, it is equivalent to relational tables like RDBMS with good optimization technique. You will not have this optimization in your database, but in Spark, it will optimize by itself. Okay. Pandas in Python. See here. An API was designed by modern big data and data taking inspiration from data frame and pandas in Python. See, data frames in Spark took inspiration from pandas in Python. Okay, pandas also create a data frame. We have seen that. But pandas is not a distributed thing. We go for the Spark for a huge volume of data. Forget about data sets. Data sets to do you need Java or Scala. Data frame is what we do in Python. Okay. So I am not speaking about data set. Data frame is organized into named collection like tables in relational database tables. Okay. So you know this. This is a thing we already seen last week. Features of data frame. Same thing you can read, petabyte, single node, state of optimization. I don't want to speak about Hive. Hive I am excluding. Spark SQL old story. Spark SQL is not about SQL. It is more than that. Create, run Spark program, write less code, read less data. Let the optimizer do the hard work. Can you see here? I just taught you how the optimizer. However you write, optimizer internally will take care of your bad code. RDD versus data frame. You know this. But still there is a way. This is a way to take the input data which I have not showed you to get your JSON data. If I do spark read.json, it will get into my Spark. Okay, Parquet file. If I want to write it as a Parquet output file, write Parquet, append, save as table. We will see this read and write function. Write less code input. Okay, so read less data. Okay, Parquet, write less operations, selecting, joining, aggregating. Common operation can be excused. So you know, joining, aggregation, filtering. Write less code, compute average. See in Hadoop you should write so much. See in Spark, so easy. Same example they have lambda. Every record you reduce by key, you add that and you collect. If you want to do in Hadoop, you should have wrote so much big, because Hadoop does not support Python and all. Yeah, this is a Java code. Write less code, compute an average, computing an average using SQL. If this is difficult, this is a Pythonic way of doing lambda and all. You can do in SQL also. In data frames, you do like this. Okay, there are different ways of doing. You know this, I just explained you. Plan optimization and execution. Unresolved, logical plan, optimize physical cost plate, and RDDs get created. Okay, so logical plan internally is expensive. See here, I think something the same example they are giving. Physical plan, it joins, it filters. Okay, so only joins relevant user. It is doing. How does it all work internally? So no internal thing. So it's very important, not only in interview, for working also. Internal thing. Project filter. Okay, logical plan. What happens in logical? Just it comes up with a proper code. Logical plan. Logical to physical. So yeah, I need not to explain. I have explained you. Optimized. Okay, writing rules. They have gone more depth. I don't want to go. I was telling right in physical or something, push down, all those things happen. I don't want to go too much into this. Yeah, know this. Okay, Spark, this is not required. Flights data, they have given an project, like an example, to take some data as an input and get into the laziness. You know that laziness grouping. Okay, so all those things you can do. What select, partitions. See, partition by, you would have already learned in SQL. If you run the same query in Spark also, it works. You have to just do spark.sql, means that basic you have to do. Create or replace temp view. After that, spark.sql, and you write this query, it will work. Performing joins. Okay. You can read this. I don't want to explain. Spark SQL example. This is good for you to know all the SQL. There are reference also. So what I'll do, I'll just download all these things what I explained you, so that what will happen is, okay, something is blocked, that's why. Hello. Okay, done. If this, it's still blocked. Hello, manage. Hello. Okay, apply. I have to do apply. Site automatic downloads. I have given hello, but let me see what's happening. Okay, now it's downloading. Okay. Okay. I think some are repeated. It's okay. I'll just. Is there any Spark SQL left? Okay, I think yeah. Spark. Okay, yeah. Why again? It's just. Okay, so now let me send you straight away so that you can practice this. You know all these things, it's very, very important. Apache Spark, okay, Spark meet Spark introduction 3 times the same thing. Okay, those two are duplicated. Okay, send. Please download everything. Okay, so you download and someone share the screen so that. Are you able to install now? Install and you are able to open the notepad. You should have installed by this weekend. You should practice, because next week I'll be giving you some problems for you only to solve. Yeah, you can share, yeah. Yeah. Can you share? Share the screen. Screen is not visible for me. Yeah. It's not visible for me. Is it visible for others? Stop share. Okay. Yeah, now it's visible. Correct. Yeah. Okay, you go to that. Leave this. Let it be like this. Go to your command prompt. Have you done the remaining steps in the command prompt? No, we did yesterday, right? So go to the command prompt then. See, yeah, okay. See, can you see here? Its container is attached. Okay, next what will happen? Pyspark is created. Container is attached. So let us wait. It's still taking. See, open the Docker. Had you stopped last time? Means open the Docker. See, last time it was running and again you are trying to run, I think so. Just open Spark, click on that. You have already ran, I think so, but you have not stopped. Just open it, open it. Okay, just see command prompt what is showing. Don't close, open. Done. Okay. Open that, click on that. That 127. Yeah. Click on that. You can click on that, right? It will open in the note in the Chrome or whatever. Just click. Or copy paste whatever you want to do. Why so many? I think it's slow. It had opened. Close and open only one. Let close remain. Let one be open. Page is not working. Just no, open. Yeah, we will see what extension was successfully linked. Okay, function found will be used. Okay, just go to the Docker. It's showing everything successful now. Just to access open the file in browser. Go scroll down completely down. Okay, it's running actually. It's running. Our server is running properly. Just click and open the link from here only. Click once. That 127. Yeah. click, it will take some time to, because if you have got means that's the Jupyter notebook, it opens by default. See, it opened now. Jupyter Lab. Open first one, notebook. Yeah. This is a notebook. You can type here your code and it gets executed. So star means it's running. After star goes off, it's completed. Okay, got right everyone. That is simple. People would have not enabled virtualization. It's simple. So if your Docker is proper, the setup whatever I have given 1, 2, 3, 4 step, you do it. It will work. Any people have any doubt? Even Sonal, you can also try. Tejasri, you can also try. Remaining people also can try. Got that right? Please install this. It's very important. So you can try all the programs. See, coding, you have already been exposed from past 3 months to coding. You can code new queries by yourself. Sorry? Yeah, you can also share. Not a problem. Who have an issue, you can share. So now you can try yourself, Vijay. You got it right? Okay. Yeah. Yeah. Okay, no configuration file found. Go to that place, go to user, go to that folder, user Spark folder. You can go to the C drive and the Spark folder, you can see. You are going to that Spark folder. Just show me, I can't see that. I can't see that folder. It's in the screen. I can see command prompt only. You close the, you minimize the command prompt, maybe I will see. I can see only that black screen command prompt. And now you share again and show me the folder. Maybe you have not kept that Docker compose YAML file. That would be the reason. You have to keep that Docker compose YAML file over there. Just share the screen again so we can see. If you don't have any issue, you can drop, or if you want to see what we are doing, you can stay. So the class has ended for today, so we will continue next week. Okay. Yeah, go to the folder now. So docker compose.yaml file. Right click and open that file. Why it is given docker.compose.yaml file? It is docker.compose.yaml file. 1 minute, what I have given? It should be docker dash compose. If you see, docker dot is there. Rename it. Okay. Now just open that file. We will see once. Okay, you have all the things properly set. Okay, now you run that. Now it will work. Because go to the command prompt, maybe if you have opened. Remove that YAML file. Docker dash compose. Yeah, we can remove that. Yeah. You have to give double quotes, double close. Close with double. You can close, no problem. At the Spark, you close it with double quotes. Okay, now do Docker. You have to use docker dash compose up. You have to use docker dash compose COMPOSC COMPOSC space UP. But first, have you opened Docker? Just show me, have you opened Docker? Go to Docker. The Docker desktop. First you have to open Docker and run that. Docker desktop is there, right? Last one. It's there, no, Docker desktop. Last one means at this side, end one. Docker desktop icon. Yeah, open it. Oh, okay. Oh, it's slow, that's why. Should I do the same process if you want to open the door? Yes, close your, see what you do every time. If you have left, restart your system next time if you want to do, and open the Docker, and after opening the Docker, go to that command prompt Spark and run that, so that your Spark starts running. Click the link, that Jupyter lab will come. That's all you have to do. Okay. Yeah. Yeah, is open. Docker desktop is up. Just show me. Okay, It's okay. Now you run Docker Compose up. Yeah. Did you run? Run it again. I didn't see. It's simple only. Some mistake could have happened. Okay, good. Thanks Vijay, Tejashri for helping Sonal. It's nice. You guys support each other. That's the way of learning, everyone. Okay, then I will be ending this session. Thank you.